The next topic we got to talk about is sketching sine and cosine functions. All right, now we have to talk a lot about vocabulary in here because it's going to be crucial for moving forward with these graphs. So we'll start with the definition of what it means to be periodic. So periodic means a pattern that is repeated after one cycle. The cycle length is called a period. So as a little side note, all trig functions are periodic. So the ones we're going to cover, sine, cosine, tangent, all periodic. And the period is a length on the x-axis. All right, so when you're talking about period length, it's a length on the x-axis. So for example, what is the period of the graph below? Is there only one way to name the period, or is it multiple ways? Well, let's start with the simple way. This is a sine wave, okay? So I know it starts here at point C and goes to point G. After point G, it repeats that pattern. So I could say C to G. Now this is going to be a value. In this example, we're just naming points, but if this were a real problem, that would be a value. Like if we're in radians, that would be 2 pi. Or if we're in degrees, that'd be 360 degrees. Okay, but just for looking at this in multiple perspectives, I'm just going to use these points, okay, and no numbers. So that's one period. Is there another way to name a period? Well, a period doesn't have to start at the origin. It could start, say, if we're at point B here, what would be the period length? Well, if it starts at B, we look in where it hits that point again. So it hits that point again at F, and then it just repeats that pattern. So we could say that the period is B to F. Okay? What's another way to name the period length, or to name a period? Well, let's say we start at A. If we were to start at A, okay, it starts going down, up, back to the x-axis and down again. So A to E would also be a period. These are all equal lengths. Okay, all the spacing between each of these points is all equal. So each of these segments, if we consider them segments, okay, along the x-axis are of equal length. So, what are the units of periods for trig functions? All right? So, we could have radians. We could have an equivalent, still angles, but in degrees. Or we could have time. When we do some application problems, we could have time on the x-axis. It's whatever's on that x-axis. So I'm going to write etc. Next, we need to define what a midline is. So a midline is the horizontal line that lies halfway in between the max and min values of your function. So again, we have a sine function that's been translated up. Okay, so our max is here, our min is on the x-axis at y equals 0. So the midline is going to be the line that cuts that graph directly in half. Okay? So, we use the midline to help us find the amplitude. Okay? The amplitude is the distance from the midline to the max. So, from here to here, this is your amplitude. Okay? Or you could go midline to min. Just realize that the amplitude is always positive. So now that we have some definitions, and we still have a couple things to piece together as far as definitions, but you have enough definitions now to see the general form of the sine or cosine function. So f of x is equal to a times sine of b times x minus h plus k. Now this should look familiar because this is transformational form of all the other functions that you do since Algebra 2. All right, so if you remember from Algebra 2, this number that's out in front of your function, okay, that is a vertical stretch or compression. So it can stretch or compress your graph this way. Well, if you stretch your graph vertically, okay, that's going to make your amplitude bigger. If you compress it vertically, that's going to make your amplitude smaller. So with trig functions, we say that this A, we give it a special name, and that name is the amplitude. All right? Now what is B? B, we're going to call the period factor, and I'll come back to this in a second. Okay? But if you remember, that's a horizontal stretch or compression. So we'll talk more about this just in a second. Okay, H, just like with in Algebra 2 when you learn transformational forms, H is a shift or translation left or right. Okay, it's a horizontal translation or a horizontal shift. And then finally K. K is your shift up or down. All right, but that K is actually going to be something specific for trig functions. K is the equation of the midline. So that K value tells you the equation of your midline, and your midline is just going to be of the form y equals K, since it's that horizontal line. All right, so now I want to talk about the period factor. What is the period factor? So B is a horizontal stretch or compression. All right? Well, if you take a graph, a trig function, let's take the sine function, whose period is 2 pi, right? 0 to 2 pi, that length is 2 pi. All right? And you stretch it horizontally, what are you changing of this graph besides the shape? Okay? Yes, if you stretch it horizontally, it'll be further down here. Okay, it won't be as tall. But what are you specifically changing? Well, you're affecting the period, right? A horizontal stretch is going to lengthen that period, and a horizontal compression is going to shorten that period. So, we can find the period based on whatever this value of B is. So the period, if we're talking in radians, is normally 2 pi. It's normally 2 pi for the parent function. Well, if we take that and divide by B, that'll give us our new period of our transformed function. Okay? Or, if you're in degrees, it could be 360 divided by B. Or whatever units you may be in, to find the period, all you do is take 2 pi, or your original period length, and divide it by B. All right, so here's our first example. For each function, we're going to find and identify the amplitude, the value of B, and the period, any reflections that may be going on, and we're asked to sketch over one period. So I've already put up, we have f of x equals 1/2 times sine of 4x. I put up the parent function of this graph, just the regular sine wave. And I want you to notice how the period is defined. I told you that we're only going to look at when we sketch. We're really focused on these critical values. The max, the 0, the min, and the other 0. Okay? The same thing's going to hold true when we sketch. We only want to find those key points. So if you notice, there's 4 key points on every period. Okay? So 1, 2, 3, 4. All right? So if you take 2 pi and divide it by 4, you see you get pi over 2. So pi over 2 is the distance between each critical value. That's important to know because that's what we're going to use to draw our new graph. All right, so let's start here. We have the amplitude. We're asked for the amplitude. So the amplitude is 1/2. It's just the value of A. All right, now we're asked for the value of B and the period. So the value of B is 4. So our period, P, I'm just going to let that be a P, is 2 pi divided by 4. It's just 2 pi divided by B, which is pi over 2. All right, so the whole period of this function happens by this point right here. So you can see it's been compressed a lot. It's been compressed by a factor of 4. All right, are there any reflections? There are none. So we need to sketch one period. Well, we know that the graph is going to start at the same point. There's no translations up or down. So the midline is going to be right on the x-axis, just like the midline of the parent. And we know that it's going to start at 0, 0 and end at pi over 2. So my question is, how do I divide up the graph so that I have 4 equal sections between 0 and pi over 2? Well, you take pi over 2 and divide it by 4, and you get pi over 8. So there's going to be pi over 8 distance between each critical value. So my first critical value is going to happen at pi over 8. The next one's going to be at 2 pi over 8, which is pi over 4. The next one's going to be 3 pi over 8. And the last one is 4 pi over 8, which is pi over 2. So it's going to follow the same pattern that the parent does. So it goes max, 0, min, 0. So it's going to go max. Now the max isn't going to be at 1 because our amplitude is only 1/2. So it's only going to go up to 1/2. Okay, so it goes max, 0, min. So the min is negative 1/2. And then back to 0. So this blue graph represents the graph of 1/2 sine of 4x. All right, let's look at another example. Let me erase the values from the last problem. So we have a cosine function this time. So we have f of x is equal to negative 2 cosine of x over 2. So I'm going to draw the cosine parent function to start. It has the same critical values as sine. But the pattern's different. It starts at a max, goes 0, min, 0, max. All right, so let's go through this. What is our amplitude? Our amplitude is 2. I know there's a negative 2 there, but amplitude is always positive. So our amplitude is 2. We'll talk about what that negative affects here in a second. All right, our B value, B is 1/2. So our period is 2 pi divided by 1/2. Okay, so that is going to be 2 divided by 1/2 is the same thing as 2 times 2. So it's 4 pi. So our period has lengthened in this case. This is a horizontal stretch. All right, are there any reflections? So you look for negatives. This reflection, if you go back to algebra 2, this is a reflection over the x-axis. All right, so it reflects over the x-axis. Now we have to sketch that over one period. All right, so first off, we need to know that this graph is going to be twice as long. Okay, so it's going to do this same pattern, but instead over 4 pi. So the period's 4 pi. Now we need to figure out our critical values. So to find out our critical values, you take the period length and divide it in 4. Because there's always 4 critical values within one period. So our critical values occur every pi radians. So we have pi, 2 pi, 3 pi, and then 4 pi. Now there's not any shifts up or down because there's no k value. And really all the questions on this assignment aren't going to deal with any shifts up or down. So I'll make a separate video dealing with shifts. We're just talking about compressions and reflections right now. All right. So our midline stays the same, but our amplitude is 2. So that means it's going to go up to 2 and down to -2. All right. Now the last thing is we have a reflection over the x-axis. So instead of starting at a max, we're going to start at a min. Zeros don't get changed from a reflection. At pi, then that's going to be at pi, because the first critical value of our new graph is pi. Okay, so we started, instead of a max, we started at a min. Then it went to a 0, which our first 0 is going to occur at pi because of that stretch horizontally. Then the next critical value of our parent happens at pi. It's a minimum. Our next critical value of f of x is at 2 pi, so it's going to be a maximum. Then we go back to a 0 at 3 pi, which is going to correspond with, or 3 pi over 2, which corresponds with 3 pi. And then we end at a max, which is going to be a min because of that reflection at 4 pi. So that's out over here. All right. So there's the sketch of one period of f of x. Now on your assignment, I'm going to ask you to verify your graph by evaluating the function at different points. So for example, if I was to say evaluate f of pi, okay, using the equation, not using your graph, use your equation because we want our equation to verify our graph to make sure that we're doing the right things here. All right, so f of pi would be -2 times cosine of pi divided by 2. There's the substitution I made. All right, so we need to evaluate cosine of pi over 2. So the cosine of pi over 2, well, there's a couple different ways to do this. Cosine of pi over 2 is right here. It's 0. Okay, all I was doing, why I used the parent, is because I was just evaluating what's in the brackets there. And cosine of pi over 2, I'm not going to use this blue graph, okay, because I'm verifying that graph using the parent. Okay, so -2 times 0 is 0, and that matches what our graph says. Let's try it one more time. Let's do f of 2 pi. F of 2 pi should be 2 if our graph is correct. So let's see if that happens. So we get -2 cosine of 2 pi divided by 2. Well, that is equal to negative 2 times cosine of pi. 2 pi divided by 2 is just pi. And the cosine of pi is negative 1. The cosine of pi, if we're following this graph, the black graph, the parent, cosine of pi is negative 1. So negative 2 times negative 1 is 2. Again, we just verified our graph by evaluating. Last problem here. So, we have y equals negative sine 3x over 2 divided by 10. So first thing I want to do is write it in kind of our general form, because this doesn't look like the form that I had on the board when I introduced the general form. So I'm going to write it this way. I'm going to write it as negative 1/10 sine of 3x over 2. And I don't need parentheses right there, because there's no confusion of what's happening within the sine function. All right, so I start just like I started all the other problems. My amplitude is 1/10, not negative 1/10. Amplitude is always positive. Okay, the period is, well, I need to identify my b value. My b value is 3/2. So my period, which I'll say is p, is 2 pi divided by 3 over 2. Okay? So, do a little the period is 4 pi over 3. All right, this was just a little side work to divide that. Are there any reflections? Yes. There's a reflection over the x-axis again, because of that negative out in front there. All right, so I need to sketch over one period. Now my period's a little bit nasty. It's not a nice clean whole number, so we need to figure out what each critical value is. So again, to do that, you take the period and divide it by 4, which is saying 4 pi over 3 times 1/4. Okay, these 4's cancel out, and we're just left with pi over 3. So pi over 3 is the distance between each critical value. So this graph is still going to start at 0. The first critical value is going to be at pi over 3, which I'm just trying to approximately get it correct. I know 1/3 is less than 1/2. Okay, now the next one is going to be another pi over 3 from pi over 3, so that's 2 pi over 3. Okay, so I can see my distance here is way off, so let's do this. Okay, pi over 3, 2 pi over 3, then 3 pi over 3, which is just pi. So there's my next critical value. And finally, we have 4 pi over 3. So what has happened to our period? It's gotten smaller, therefore this is a horizontal compression. All right, so there's a reflection over the x-axis, and we also have to include our amplitude. So our amplitude is 1/10. So here's 1. 1/10 is tiny. All right, so we're going to have the same pattern except flip. So instead of going up to a max, we're going to start down to a min. So our min is going to be at pi over 3, negative 1/10. And then after our max, we go back to a 0. So going to have a 0 at 2 pi over 3. Then after that, we went down to a min, so this is going to be a max at pi, and it's not going to be way up there, it's going to be way down here. Okay, and then finally, it comes back to a 0 at 4 pi over 3. So now if I sketch my graph, that's what it would look like. And I should have had this as a dotted line so we don't get confused with what's my real graph and what's the parent. But there's your graph. So this assignment's going to have you practice just that. Let me know if you have any questions, and have a good day.